let me expand a little bit. A piano keyboard has 88 notes on it, and each note, you probably don't think about this even if you play a piano, but each note has an assigned frequency. You hit that note, you hear a tone that is a very precise frequency. Those are the actual frequencies for all 88 of those. They are defined, and if that key is not on that particular frequency, we would say that piano is out of tune, right? So let's suppose that in 1947, Grandma bought a brand new piano, and this is one chord from that keyboard, from the chord below middle C, so it's from low C to mid C, 13 notes. Each of them has a defined frequency, and when that piano was delivered to Grandma, every one of those 13 keys was right on, or very close to the defined frequency for each of those notes. And as happens with pianos, let's assume that for whatever reasons, Grandma's piano spent 50 years in the attic. And maybe the grandchildren discover it, bring it down, dust it off, and check it out. Well, after 50 years in the attic, things had changed. And if you hit those 13 keys now, you'll find that they're not on the precise frequency. The piano is out of tune and needs to be brought back into tune. It needs to be tuned up by a guy who knows what he's doing. He will bring tuning forks. He will listen very carefully, adjust each of those keys until it's back where it should be. And the same thing happened to Grandma, by the way, in those 50 years. If you look at her genome, and instead of 88 keys, we're looking at 25,000 keys in the genome, where each key is one gene. And to be properly functioning, if we looked at Grandma's genome when she was 20 years old, no oxidative stress to speak of, those genes would have been in tune. These are the 400 genes, and this is real data from my laboratory, from human cells, 400 genes that respond most to Protandim being added to the culture medium. And the height of there are 400 little bars here, and you can't see them individually, but the height of each one tells you how frequently that gene is being expressed, how often that blueprint is being called out of the nucleus of that cell and functionally translated into the product for which that blueprint encodes. This is the way those 400 genes are expressed when oxidative stress is low. So we could call this a properly tuned genome. Because you can't see the individual genes when there are that many, I've taken a little area in the center part of this randomly in that red box, which is about 63 genes, and we're going to look at that a little more closely. They're now spread out. You can see them individually. The name of each gene is on the bottom of the axis, and they don't mean much to you, and some of them don't mean much to me. Some of them, in fact, are of unknown function. We know the gene is there. We know its sequence. We don't fully understand what that gene does. But in other cases, we know exactly what it does, what disease it may be involved in. So this is, I think, 63 genes chosen just to be in the middle of that range. And this is how they're expressed when oxidative stress is low, specifically when Protandim is in the medium. If we grow, and this is in a human cell line, if we grow these same cells without Protandim under conditions that have oxidative stress, what do you think it looks like? It looks like that. Okay? So that's equivalent to Grandma's piano after 50 years in the attic. And the difference between that and this is Protandim. All right? It's a dramatic illustration. And let me point out to you, too, how dramatically things have changed. Protandim was developed primarily to affect 3 gene products, superoxide dismutase, or SOD, catalase, and glutathione peroxidase. And the literature as of 5 years ago, led us to believe that this could happen, this would happen with Protandim. And indeed, it did affect those 3 genes. What we've learned in the last 5 years is that it affects not only those 63 genes, but these 400 genes. All right? So 3 of those are SOD, catalase, and glutathione, or glutathione peroxidase. Have we realized that Protandim does a lot more than that? You bet. We went from 3 genes to 400 or 500 genes that we're now talking about. Each of those genes has its own story. And your eyes would quickly glaze over if I went through the first 200 of those.